Another important reaction of alcohols and phenols are oxidation reaction. So here in oxidation reaction, in this reaction there is a carbon oxygen double bond forms by breaking OH and CH bonds in alcohol. So in such a cleavage occurs in the oxidation reaction. So we can call it as dehydrogenation reaction. Why? Because there is a dihydrogen loss from the alcohol. That's why we can call it as dehydrogenation. So removal of hydrogen is known as dehydrogenation reaction. So if we check this reaction, we can say that here we can see there is OH bond will break. Here we can see that the OH bond will break similar to this. Hydrogen also eliminating. Here this OH bond will break and this hydrogen also will eliminate and form carbonyl compound. So if we check the primary, secondary and tertiary alcohol, they will form different compounds while oxidation. If we check primary alcohol will undergo oxidation reaction, will form aldehyde. That is, primary alcohol will give aldehyde. And further oxidation to this aldehyde which form carboxylic acid. So we know oxidation means addition of oxygen. So here you can see the double bond of oxygen occurs. So there is addition of oxygen. Here only one oxygen, but in the case of aldehyde there are two oxygen. Further if we oxidize it will get carboxylic acid. We can use many oxidizing agent, and for example here you can see we'll get first aldehyde. If we take secondary alcohol will undergo oxidizing reaction in the presence of an oxidizing agent. It will form ketone. So secondary will give ketone. Ketone having the compound with functional formula C double bond O. So secondary alcohol will form ketones. Tertiary alcohols do not undergo oxidation reaction. But if we are using the strong conditions such as strong oxidizing agents such as KMnO4, we can call then we'll get strong. If we use strong oxidizing agent, we'll get such as KMnO4, K2Cr2O7, will get carboxylic acid. They will directly form carboxylic acid. So if it is primary alcohol which will give aldehyde, if it is secondary alcohol which will give ketone, if it is tertiary alcohol it will not produce or it will not undergo oxidation reaction, but in strong conditions such as using strong oxidizing agent, it will form mixture of carboxylic acid which having the lesser number of carbon atoms is formed. The next type of reaction is dehydrogenation reaction. Dehydrogenation means removal of hydrogen. So when the vapors of primary or secondary alcohol are passed over heated copper, dehydrogenation takes place and an aldehyde or a ketone is formed. So if you take primary, we have already discussed this. If you take primary alcohol and secondary alcohol, primary alcohol will produce aldehyde, secondary alcohol will produce ketone. and tertiary will give alkene. Then let's check reactions of phenols. Phenols will undergo electrophilic aromatic substitution reaction. So, electrophilic substitution reaction are already we studied. So, in phenols, benzene ring directs the incoming group to ortho and para position if a group having this OH group. We know a phenol already having a OH group in it. OH group. So, in electrophilic substitution, if there is any electrophile attached to this, the electrophile is attached to either ortho or para positions. Ortho and para position. Let's see the reactions. For example, nitration. With dilute nitric acid at low temperature, phenol yields a mixture of ortho and para nitrophenols. Here you can see this phenol. So, we'll get the mixture of ortho nitrophenol and para nitrophenol. And if we are using dilute nitric acid, we will get the mixture of ortho and para nitrophenol. But in the case of, if you are using concentrated nitric acid, we will get 2,4,6 trinitrophenol. This compound is known as picric acid. So, the product yield, that is the amount of product produced, is very less. So, we can see the reaction. If it is react with concentrated HNO3, will get 2, 2, 4, 6 trinitrophenol. Its chemical name is picric acid. Next reaction is halogenation. Halogenation, we know what is halogenation. Halogenation is the addition of halogens. If we check, if we are using different experimental condition, we will get different compounds. When the reaction carried out in solvents of low polarity of such CaC, ClTr, if we are using low polarity compounds, we will get monobromo compounds or monochloro compounds. And we can see the reaction if we are using bromine in milder conditions, we will get bromo compounds. And when phenol is treated with bromine water, so it is strong condition, we will get 2,4,6 tribromophenol as similar to 2,4,6 trinitrophenol. Then next important naming reaction is Kolb's reaction. So it is very important naming reaction. So in this reaction, phenoxide ion generated by treating phenol with sodium hydroxide. If we are treating phenol with sodium hydroxide, so there will electrophilic aromatic substitution will occurs, and we will get sodium phenoxide. So this is known as Kolb's reaction. We can see here. So the first step is, if phenol is treated with sodium hydroxide, it will give sodium phenoxide, that this H and this OH will give H2O here. Then the Na attached to this oxygen. And the second step, then if we treated it with carbon dioxide and protonation, will get salicylic acid, the compound which contain OH and COH in a benzene ring is known as salicylic acid. So it is very important reaction. So the another important naming reaction is Remer-Tiemann reaction. Remer-Tiemann reaction. So it is a phenol is treating with chloroform in the presence of sodium hydroxide. A CH group is introduced in the ortho position, that is aldehyde group is introduced in the ortho position in the benzene ring. This reaction is known as Remer-Tiemann reaction. So in the case of Kolb's reaction, salicylic acid, acidic group introduced COOH bond, but in Remer-Tiemann reaction, CHO group is introducing. Here you can see the phenol is treated with CHCl3 in the presence of aqueous NaOH, we'll get an intermediate, and further if we treat it with NaOH, we'll get salicylic aldehyde. We'll get salicylic aldehyde. So this is the Riemann-Tiemann reaction. Then reaction of phenol with zinc dust. If phenol is converted to benzene ring, heating with the zinc dust. Then oxidation of phenol with chromic acid produces conjugated diketone. This diketone is known as benzoquinone. Here you can see the reaction. The phenol is treated with chromic acid. This is known as chromic acid. You'll get benzoquinone. And in the presence of air, phenols are slowly oxidized. We know air contains oxidation reagents, so it will form quinones. So these are the chemical reactions of alcohol and phenol. There are two naming reactions. These are very important. So I hope all of you understood today's topic. Thank you.